All right, this is advanced algebra. Um, Notes for topic 8, section 3, and this is quadratic functions in standard form. So we looked at quadratic functions in uh, graphing form, vertex form, whatever you want to call it. Now we're going to look at equations in standard form. So standard form is ax squared plus bx plus c. A cannot equal 0 because if a is 0, that x squared term doesn't exist and we don't have a quadratic function, we have a linear function. The vertex, to find the vertex, we use the opposite of b over 2a. So whatever this coefficient of x is, we take the opposite of it, and then we put that over 2 times whatever a is in the problem. Okay? And basically then that's it. We can jump right into some examples here. So I have the quadratic function f equals 2x squared plus 4x plus 3. So I'm going to just rewrite that over here. F of x equals 2x squared plus 4x plus 3. I can see my paper over a little bit. Okay, so to find the vertex, x equals the opposite of b over 2a. And again, b is in front of the x, a is in front of the x squared. Okay, so in my problem here, b is 4, the opposite of b would be negative 4 over 2 times a is 2. So I have negative 4 over 4, which is negative 1. So my vertex, the x-coordinate of my vertex is negative 1. To find the y-coordinate, I take negative 1 and I plug it in here for x. So I get y equals 2 times negative 1 squared plus 4 times negative 1 plus 3. And let's see, this is going to be 2 minus 4 plus 3, negative 2 plus 3 is 1. So the y-coordinate of my vertex is 1. My vertex is at negative 1, 1, which is right here. Okay. The axis of symmetry is the vertical line going through that vertex. Vertical lines are x equals lines. So this is the vertical line x equals negative 1. We know the domain is going to be all real numbers. The range we'll look at after we get the graph. And then I'll talk about these other two things. Okay. So same thing, I do the same thing to find, another point. I'm going to pick a value of x, a logical one though. I'm going to plug it into 2x squared plus 4x plus 3, and I'm going to find a y value. Give me an ordered pair that I can graph. And by logical point, what I mean is that here I am at negative 1. I'm not going to plug in 5. Okay, I'm going to plug in what's right next to negative 1, which is 0. So if I plug in 0, I get 2 times 0 squared plus 4 times 0 plus 3. This is 0 plus 0 plus 3. So there's the point 0, 3. And then again, axis of symmetry means there's a point over here. It's reflection. What's right next to 0? 1. So 2 times 1 squared plus 4 times 1 plus 3. This may be too big. That's going to be 2, 6. It's going to be 9. And that's off our graph. So what we have is sufficient. We know what the parabola looks like. So it looks like this. Okay. The y-intercept. The y-intercept is where that parabola intersects the y-axis. The y-intercept is, if I let x be 0, what do I get for y? And here I got 3. So To find the y-intercept, we let x equals 0 and solve for y. Okay? The x-intercepts for right now, we're just going to say yes or no. Does it have x-intercepts or does it not have x-intercepts? And if we look at the graph, is the graph crossing the x-axis? Because the x-intercepts are where the graph crosses the x-axis. This graph does not. So does it have x-intercepts? No, it does not. And then as I said, when we learn how to solve these things in the next chapter, we'll be able to find those x-intercepts and tell everybody what they are. Okay. So we just keep rolling along here. Vertex, the equation is f of x equals x squared plus 2x plus 4. So the x coordinate of the vertex is the opposite of b over 2a. B here is 2, a is 1. So I have negative 2 over 2 times 1, or negative 1. And then to find the y coordinate, I plug that in. Y is negative 1 squared plus 2 times negative 1 plus 4. Then let's see, what's that going to be? 1 minus 2 is negative 1 plus 4 is 3. So my vertex is at negative 1, 3. Negative 1, 1, 2, 3, right here. Axis of symmetry, x equals negative 1. It's the equation of this vertical line. It goes down through my vertex, right? And it is x equals negative 1. Domain, all real numbers. So now I'm going to plug in a point right next to negative 1, which is 0. If I plug in 0, I get 0 squared plus 2 times 0 plus 4. 0 plus 0 plus 4 is 4. So 0, 4 is a point. Axis of symmetry. That's also my y-intercept. 0, 4. And then I don't think I'm going to be able to plug in 1. 1 plus 2 is 3 plus 4 is 7. 2, 3, 4, 5, 6, 7. Oh, I can. If I plug in 1, I get 7. And then my axis of symmetry would put me over here. And then there we go. The x-intercepts, are there any? No. What's the range? The lowest point here is 3. So the range is y is greater than or equal to 3. Now it's always not going to come out pretty. It can get pretty sloppy, and this book is notorious for giving you decimals. So let's look at it. G of x is negative 0.75 x squared plus 3x minus 4. So the x coordinate of the vertex is going to be the opposite of b, negative 3, over 2 times a, 0.75 times 2 is 1.5, and it'll be negative 1.5. And negative 3 divided by negative 1.5 is 2. That was nice. And then if I plug that in, y, negative 0.75 times 4 plus 6, that's going to be negative 3 plus 6 is 3 minus 4 is negative 1. So my vertex is 2, negative 1. Axis of symmetry, x equals 2. Domain, all real numbers. 2, negative 1 is right here. I'm going to plug in 1. If I plug in 1, I get negative 0.75 plus 3 minus 4 is negative 1. Negative 1.75. So if I plug in 1, I get roughly right here, or right here. If I plug in 0, oh, wait a minute, negative 1.75, that's positive 1.75. Negative 1.75 would be down here, and down here. And if I plug in 0, I get 0 plus 0 is 0, minus 4 is negative 4. And there again, 1, 2, 3, 4, there's my y-intercept. So 0, negative 4 is my y-intercept. And 1, 2, 3, there's my reflection. And there's my parabola. X-intercepts? Nope. Doesn't have any range. Now this is the maximum it's going to get at negative 1. So we say y is less than or equal to negative 1 for the range. Okay. And again, there is a story problem here, and I'm going to save that for class when we start this lesson. So that's it.